This is a big free response question lesson, okay? The quiz, when we did the quiz, relative maximum, relative minimum, calculating all those things, increasing, decreasing, concave up, concave down, those are more multiple choice questions. So when you see those questions again on the test, they'll be multiple choice questions. This, though, is free response. Analyzing graphs, that's pretty much what we're doing today, analyzing graphs, okay? Okay, so let's go through this. Let's go through this. First day, I go through it very slowly because sometimes it's easy. You're kind of like, I get it. Okay, I get it. Sometimes it's hard. Sometimes it's just, it takes a little bit of time to make those connections. So I'm going to go really slow today. For some of you, it might be too slow, which is fine. You know, you go faster than me. It's okay to go faster than me, but I don't want you going, I don't want to go over anyone's head. Okay? Okay, so first thing we got to do is we have a function here, right? The function f is defined, means it's continuous, and differentiable, means it has a derivative everywhere, on the interval from -6 to +6, the closed interval from -6 to +6, okay? The graph of y equals f prime, in other words, the derivative of f, consists of a semicircle and 3 line segments, which is shown. So the first thing is, this graph isn't the graph of the original, right? This graph it's the graph of f prime. It's the graph of f prime. It's the derivative graph. So everywhere on this graph isn't y values, it's slopes, right? For example, let me give you a point. Let's pick this point right here. You go, oh, that's 4, 2, right? That's 4, 2. 4 is the x, 2 is the y. No, that's not the way it works. Because this graph isn't the original, it's the derivatives. So what 4, 2 says is, when x is 4, the slope of the original at 4 was +2. It was increasing. So when x is 4 on the original, it was increasing, okay? So you got to be careful with that. So when you're talking about the original and you're looking at points, we're looking at derivatives, right? 2 is a derivative. 2 is the slope when x equals 4, okay? And it's true for all of those points, every point along that guy. Okay, so. All right, so here we go. Okay, so first question. Find the x-coordinate of the critical points for the original. So we have to use this graph, which is the derivative, right? It's the derivative. We've done this before, but not like this. It's kind of taking what we've done and turning it on its head and looking at it from a different angle, okay? So we found critical points. You guys did that on the quiz a number of times. Found critical values, critical points. You guys did that a lot on the quiz yesterday. And you've done it before in the class. But we've never done it like this, okay? So we got to find the critical points on the interval from -6 to +6, and then we have to justify our answer. Okay, so tell me about critical points. How do we find critical points or critical values? What do we do to find those? Before that, even before that.
Find the derivative?
Find the derivative, find the first or second derivative. To find critical values, to find critical points, that's a first derivative thing, right? And then what do we do to the first derivative? We set it equal to 0, right? That's going to be our justification. Okay? So critical points occur when you find the derivative and set it equal to 0. We're going to have to use our graph to find those points. Okay. So we need to find where the derivative equals 0. How do we do that using the graph? We need to find where the derivative equals 0, because that's a critical point. How do we do that using the graph?
Figure out where the slope is at 0?
So normally we would think about slopes, right? But aren't we looking at slopes? This is the graph of this guy, right? And this is what we need to find. So where on the graph is this true? Why negative 4 and 0? You're right. Why negative 4 and 0? That's where the derivative is 0. That's where the derivative is 0. The derivative is 0 here and here, right? This is negative 4, 0. This is 0, 0, right? What did we say about the y values at each point? They weren't y values. What were they? They were slopes. They were derivatives, right? So that's when the slope is 0. Okay? So there's going to be two spots. X equals negative 4 and x equals 0. Because why do we know why are those two spots our answers? What's equal to 0? The derivative is equal to 0, yeah. Because f prime of x equals 0. You've done all of this before. The thing is, you've never done it like this. It's kind of taking something and looking at it from a different angle, because they don't give you, if I gave you this, if I said f of x is x cubed plus 3x squared minus 10, you guys would know how to find the critical points. Oh, take the derivative, set it equal to 0, solve it. You guys have done that before. This is the same exact thing we just did. This is the same exact thing, but just not an equation. It's a graph. Okay? We use it the same way, though. Okay, so next question. Find the x-coordinate of each relative extrema. That means relative maximums and relative minimums. Okay? So there's two things we got to find. We got to find the relative maximum and relative minimum. So tell me about relative maximums and relative minimums. For example, if I wanted to find a relative maximum or a relative minimum for this example that I have on the board, what would you do?
Figure out which one's the highest and which one's the lowest.
Be more specific.
After you find
So for this problem, so let's say I'm doing this problem. How would I find the relative maximums or the relative minimums for that problem there? What's the first step I would do?
Find the derivative.
Find the derivative.
Equal it to 0.
Equal it to 0.
And then put it on a line.
There you go. Figure out where it's increasing, decreasing, right? Figure out where it's increasing and decreasing. So find the derivative. You said find f prime. Set it equal to 0. And then number line, right?
Wouldn't you put it on a table for finding maximums and minimums?
That's only for absolute. For absolute, you would. But for relative, we just use the first derivative test, right? We use the number line. Good. That's what we're going to do. Here's my question. How do we do it using that guy there?
You put it in the direction of the slopes.
And the answer is the same way. The same way. It just looks different. So the first thing we need to do is find the derivative. How do we find the derivative? It's already there. Yeah, trick question. It's already there. The derivative is done for you. Second thing, find out where it equals 0.
Negative 4 and 0.
We just did that, right? We just said that the derivative is 0. There and there, right? So it's going to be negative 4 and 0, right? how do we do increasing, decreasing? Because didn't we plug in numbers, right?
The direction the slope is going.
We can use the slopes, right? How do I find slopes using the graph?
If you're going positive or negative.
So be more specific. When what's positive or negative?
When the
Y value?
derivative
The y values. There you go. This is the slopes already. These are the slopes already. So when you want to find the derivative, you just look at the y values. The y values are the derivatives. You don't have to plug in anything. It's already done for you. Okay? So -4 and 0 are going to be the two guys on here. So before -4, is it going to get a plus or is it going to get a minus? Y plus. You're right. It's actually a plus because the y values are positive. If the y values are positive, it would get a plus here. Okay? So here, the original, I don't want to use yellow. Had a positive slope. Another word for positive slope? Increasing. Where else was it increasing?
0 to 4.
After 0, right? After 0. Those are positive y values. Those are positive y values all the way to the end. Where did it have a negative slope?
From -4 to 0.
There you go. In between, right? Negative slope. If something has a negative slope, where's it going?
Down.
Decreasing, right? Decreasing. Okay. So let's put on our thinking caps here. Where's the relative maximum and where's the relative minimum? We know it's going to be -4 or 0, right? -4 or 0 are either going to be a relative maximum or a relative minimum.
-4 is going to be a maximum and 0 is going to be the minimum.
So yeah, so think of this. -4 was increasing before because it had positive slopes, positive y values. After -4, it was decreasing because it had negative slopes, negative y values. Afterwards, it was increasing. And then you're going to read it like you would before. Increasing before -4, decreasing after -4, that makes a relative maximum. That makes a relative maximum. Decreasing before 0, increasing after 0, that makes a relative minimum. Justification. When do you know if you have a relative maximum or a relative minimum?
When it goes from increasing to decreasing or decreasing to increasing?
When the slope changes from positive to negative or vice versa, right? Maximum occurs when f prime changes from positive to negative. From positive to negative, that makes a maximum because f prime switches from positive to negative. That creates a maximum. What creates a minimum is the opposite. When f prime switches from negative to positive. That creates a minimum. So if you look at -4 and 0 on the graph, is there a change there? What's the change at -4 and 0 on the graph?
It's negative.
It goes from positive to negative or negative to positive, right? There's that switch. That's the switch we're talking about. That's the switch we're talking about. Okay? Okay. Next one is increasing, decreasing. Increasing, decreasing. Where is this guy increasing, decreasing? Give you a hint.
Decreasing at -6 to 4.
So from -6 to 4, is it increasing or decreasing?
Increasing.
Yeah, it's actually increasing. From -6 to -4, it's increasing. But I'm like, this is the biggest problem I see. That's going down, Mr. Flores, that's going down. Why did you say it's increasing? Because you're looking at it like if this one was the original. This is not the original. This is the derivative. The derivative doesn't tell me about y values. The derivative tells me about slopes. This green part here has positive y values. So that means it has positive slope. If it has a positive slope, it's increasing. It's increasing. Okay? Then we go here. These guys are below the x-axis. They are decreasing because they have negative slopes. After 0, positive y values, which mean positive slopes, increasing. Okay? So, we would say increasing
Oh, yeah.
over -6 to -4. Or from 0 to 6. From 0 to 6. Because we'll get to the justification in a second here. Decreasing over -4 to 0. Because, so just as important as the answer for these is justification. You're going to get the same number of points for the answer as you will justification. So if you give me the correct justification but the answer is wrong, you'll get half credit, even if you got the answer wrong, or vice versa. I have some students that are like, they give me but they forget the justification, or they get the justification wrong. Then I can only give you half credit. Okay? So the justifications are very, very important for these. Okay, so how do we know that it was increasing from -4 or -6 to -4? How did we know it was increasing from -6 to -4 and also from 0 to 6? How did we know? Because the slope is positive. The slope of the original is positive. Yeah, f prime. F prime is positive, greater than 0. You can use notations like that. You can say f prime is positive in words, but you don't need to. You can use symbols greater than 0. Vice versa, decreasing because f prime was negative, less than 0. You don't have to use the symbols. You can just say is positive, or as long as you put f prime. Don't just put b. I've had students do this. I've had students say because it's positive. I know it's positive. What is it? Right? Don't use it because you're referring to something that you need to refer to. Whatever it is, tell me what it is. Identify it. Before you call it, identify it. Okay? All right, next one. So that's first derivative. That's how to do first derivative. Now we're going to talk second derivative. Point of inflection is second derivative. Point of inflection is second derivative. Point of inflection is when second derivative does what? So not positive or negative, because that's concave up and concave down. It's in between those. What's in between? Zero. It's kind of the critical value for second derivative. Okay. Go back to our example. Tell me how you would find the critical value, or tell me how you would find point of inflection for this guy. What are your steps?
Get the first derivative and get the second derivative.
So first thing you got to do is find the first derivative. Second thing you got to do is find the second derivative. Good, keep going.
And then you set it equal to 0.
Set the second derivative equal to 0, right? That's what we do, right? Okay, so let's do step 1. Find the first derivative. How do we do that?
You just look at the graph.
Look at the graph, right? Look at the graph. Done. First derivative's already done because that's this picture right here. Okay? Okay, now's the hard part. How do I find second derivative using that guy? Or better yet, how do I know when second derivative is 0? So, let's go back. So the derivative is the y values. What is the second derivative gonna be then? If the first derivative is y values, what's the second derivative gonna be?
The y value.
That's first derivative. First derivative is the y values.
The derivative of the y values?
Slopes, right? Slopes. Right? Y values, slopes, and then increasing, so increasing, decreasing, in other words, that kind of thing. Okay, so we want to figure out when this guy equals 0. So what am I looking for? When what is 0?
Slopes?
Slopes are 0. So look at this graph here. Where is the slope of the tangent line going to be 0? When is the slope of the tangent line going to be 0?
6, 0, negative.
Where is it? Say again.
6, 0, negative 4.
No, let's see. Wait, where am I at?
4 and negative 6.
So where is the second derivative? Here we go.
Negative 6 and 4.
Negative 6. No, not negative 6. What?
Negative 2.
Negative 2. Look at negative 2. If I was to draw a tangent line at that dot there, that orange dot there, would it be increasing, decreasing, or 0? 0. So negative 2 is one of them.
And 4.
Yes, why positive 4? Positive 4 is another one. Why positive 4?
Because if you draw a tangent line, it's going straight from flat.
Because that is a corner. It's a corner, right? Corner, cusp point. Okay? So negative 2 is when the top equals 0. Positive 4 is when the bottom equals 0. Okay? So let's go down here. concave up, concave down. Oops, not concave up. So we haven't answered the last question. Point of inflection. So we would say points of inflection at x equals -2, x equals +4. Because, why did we pick those two spots? Slope was 0, but the slope wasn't 0 for the other guy. The slope was 0 for -2, but the slope wasn't 0 there. But what did the slope do at 4? It made a corner, which creates what to change? Say it again? Which creates what to change? What's changing? Yeah, so at corners or cusp points, what changes? The slope, right? Because the slope changes. The slope changes from decreasing to increasing at the first one, and then from increasing to decreasing before. So F double prime, because F double prime switches signs.
This can only be a point of inflection if, like, it's has a slope of 0 and then it switches.
Yes.
Okay. So that's why, like, -6 isn't one, because it just.
Yeah, because -6, it wasn't anything before. There was no slope before -6.
But if, like, there was a slope and it was, like, going down.
Yeah, if it was like,
Considered one?
if it was like this, right? If there was an arrow like that, then I would say -6 definitely too. Or if there was any change in direction, I would count it as a point of inflection. Change of sign, switch of signs, whatever. Yeah, whatever you'd like to use. Okay. So next thing is concave up, concave down. How do we know when something is concave up? How do we know when something is concave down? So if this guy, you guys did this on the quiz again yesterday, how do we know when that guy is concave up and concave down?
We get the first derivative, then we get the second derivative, then we plug it to equal 0 and see if it's positive or negative before and after.
If what is positive or negative, you're right.
Slope or the
Second derivative, right? So when the second derivative is positive, that's concave up. When the second derivative is negative, that's concave down. Those are going to be our justifications. And it will help us find what we need to find. So here's my question. When is second derivative positive and when is second derivative negative? So let's see, concave up, concave down. Okay, that's what we got to find. Concave up, concave down. We already have our justification. I know when the second derivative is positive, it's concave up. So let's go look at the graph. Where is the second derivative? Looking at this graph here, this graph is of f prime. When is this graph going to be concave up? See, that's the hard part there.
before or after -2?
So it's going to be, so we know -2 and +4 are critical or points of inflection. So before, between, after, right?
Between them is going to be positive.
So again, we're looking for the second derivative to be positive. And if we're looking at the graph and we're talking about second derivatives, what are we referring to? The slopes. So in other words, where are the slopes positive? Where are the slopes negative?
They're positive
So on this graph.
So it's negative at negative.
So yeah, so at the beginning, positive slope, negative slope.
Negative.
Negative slope, and then at -2 I change, right? So now it becomes
Positive.
positive slope up until,
4 where it goes negative.
and then afterwards it goes negative, right? Okay, so we got the intervals, we just got to figure out which one of those intervals. So it's going to change, there's a change here and there's a change here. So where is it concave up?
At -2 to 4.
-2 to 4. Why was it -2 to 4?
Because the slope is positive.
Because the slope is positive. Good. From -2 to 4, because the slope, which we're calling f double prime, is positive. Where is it concave down?
-6 to -2 and then 4 to 6.
Before -2, after +4, right? So negative slope there, negative slope there. From -6 to -2, and from 4 to 6. This one is because f double prime is negative. Okay. Okay, so now, another popular question is they like you to find equations of the tangent line for the original. Equations of the tangent line. So equations mean y minus y1 equals slope x minus x1, like you guys have done before, right? And we got to fill in y1, slope x1 for this guy. Okay, so what do we need to fill in this guy? We need a slope, right? We need a slope at when x is -2. We need a slope when x is -2. How do we find a slope when x is -2?
When the y value is -2.
There you go, right? What is the slope? Slopes are y values. First derivative is y values. So when x is -2, what is the y value?
Isn't it when y is -2?
No, when x is -2,
It's -2 as well.
it's -2 as well. That means the slope, because this point is at -2, -2, right?
The slope is -2.
So the slope is going to be -2. We got a slope. What else do we need?
The y and x value.
X and y. One of them we know. Which one do we know?
The x value.
X is -2, right? What's y? How do you know it's 4?
Because f at -2.
They told you, yeah. -2, x is -2, y is 4. So x goes here, y goes here.
So it would be x plus 2.
So it's y minus 4 equals -2, x plus 2. Done. We didn't have to do any calculations. I didn't have to crunch any numbers. I just had to look at a graph. So like I said, it's at the same time, it's the hardest thing and the easiest thing we've done. Because there's no crunching numbers. There's no nothing. But you got to be able to make sense of it. What's up?
Are they always going to give us y? Or we have to go find something?
For this chapter, they will. For this chapter, they will. In next chapters, they won't give you y. But this chapter, because you got to use integration to find y, this chapter, they will give you x and y.
So all we're finding is basically the slope.
That's it, yeah. And knowing that -2 and +4 are x and y, yeah. Okay, so now what I just did right there was I gave you a fish, right? What do they say? If you give a person a fish, they can eat for 1 day, right? That's it. But if you teach them how to fish, they'll be good for life, right? So what we just did here in example 1 was I gave you a fish. You're happy right now. But then tomorrow when you come back, it might not have clicked yet. So now I'm going to teach you to fish. Okay? So here we go. How to look for answers. This is how to look for answers, guidelines. So we're going to go over the problems we just did and how we figured out this was the answer. Okay? Okay. So the critical points. The critical point was A. Question A was the critical point. We answered it, right? We got x equals -4 and x equals 0. How in the world did we get -4 and 0? If I was to give you another graph that didn't look like this, where would we always look? When the y value equals 0. Yep, when the y value equals 0. So let's write that down, yeah. So when the y value, so I'm going to say it a little differently. Essentially, it's the same thing. But when it touches the x-axis, that's 0, right? So anytime it touches the x-axis, or has a point where it is undefined. We didn't have that in this problem, but in the future it could be too. It is undefined. So how do you find critical points using the derivative graph? You either look where it touches the x-axis or where a point is undefined. On our graph, we didn't have any undefined. So that's why I gave you that one. Okay. Relative maximum, relative minimum. We said for this graph, the relative maximum is from -6 to -4, and from 0 to 6. From 0 to 6, right? The green and the green. The green was, sorry, wait. No, sorry. We had a relative maximum, sorry, I jumped ahead one. We had a relative maximum at -4, right? At -4 was a relative maximum. How did we know that? How did we know it was at -4? Wait, let me do this.
Because it was a curve?
No, at -4. It's not a curve. -4 is -4.
Because it went negative? The slope changes.
The slope changes, right? And the slope was the y values, right? So when the y values changed from positive to negative, okay? So when the graph crossed the y-axis or crosses the y-axis from one direction, from positive to negative, y values. Oops, I'm going to write this. From positive y values to negative y values. From positive y values to negative y values. When it does that, you got yourself a relative maximum. The opposite's going to be true for relative minimum. When the graph crosses the y-axis from negative y values to positive, I'm going to use the words. It's positive and negative. to positive y values. Okay. Increasing, decreasing. When did we know the graph was increasing, decreasing?
When the slope is positive or negative? Or
And the slope is what? You're right. When the slope is positive, it's increasing. When the slope is negative, it's decreasing, right? So looking at the graph, how do we know when the slope is positive and the slope is negative?
when it's positive y value?
When the y values are positive, yep. Positive y, slope is positive, increasing. Negative y values, slope is negative, decreasing. In other words, when is it above the x-axis? When is it below the x-axis? Above the x-axis, you got yourself increasing. Below the x-axis, it's decreasing. Points of inflection. How did we know that -2 and +4, how did we know that -2 and +4 were points of inflection? There you go, right? When the slope of the graph changes or switches from either positive to negative or negative to positive. When the slope of the graph changes from positive to negative or vice versa, negative to positive, you got yourself a point of inflection. Okay. Concave up, concave down. Concave up, concave down. How did we know from -2 to 0 was concave up and from 0 to 4 was concave up? How did we know those were concave up? There you go. The slope of the graph is positive. Yep. Slope of the graph is positive. Means it's increasing. When did you know when it's concave down? The opposite reason. Slope of the graph is negative. Decreasing. Okay. All right. Last one. Because tomorrow, first thing tomorrow, I'm going to give you your own problem. Okay, I'm going to ask you all the same things. Critical points, increasing, decreasing, maximum minimums, points of inflection, concave up, concave down, all of those good things that we just did. But I'm going to give you your own. So the last thing, how do we find the slope? Because that's really all we did, right? They gave us the x and the y. But how did we find the slope of the original function? How did we find the slope of f of x?
Where x is where y is at when x equals a certain value.
Yes, the y values, yeah. The y values of the graph. At the same x value. So the y value, I should put y value because it's only one, y value of the graph of f prime at the same x value.
So it would have to be the same things basically.
So whatever the y is at that x. So if it says like when x equals -2, it's whatever the y is at when x, that's what it means. That's what it means, yeah. Oh, I should put that, right? It's kind of confusing. At x equals whatever, right?
What cat?
Okay. All right, so we're not going to do example 2 today because we're running low on time, but we got some time. Let me give you a practice problem. Let me find a practice problem here.
Do it on the back side.
Other days.
No, this one you don't even got to do. You don't even got to write this one down. You don't even got to write these down. I just want you to be able, because it's all about figuring out where they are, right? You're not really crunching anything. You're just kind of looking. So let me find one. Let me find a good one. There we go. So it goes from -9 to +9.